Particle theory states that all matter is made up of tiny particles that are constantly in motion due to their kinetic energy, which is their moving energy. Due to the variation in this energy between different substances, there exist different states of matter. Matter can exist as a solid, liquid, or gas. And in this video, we are going to explore how the particles behave in each of those states of matter. There are 4 different aspects we tend to look at when comparing particles in a solid, liquid, and gas. They are particle movement, the object's shape, object volume, and compressibility. In a solid, the particles remain in a fixed position and they vibrate. Solids have a fixed shape, meaning that whatever container you put it in, it will still stay the same shape. And solids also have a fixed volume. They can't be compressed, which means squashed. In a liquid, the particles aren't fixed and they roll over and around each other. When we draw diagrams of liquid particles, we usually add arrows to show that the particles roll over and around each other. Liquids also don't have a fixed shape. Rather, they take on the shape of their container. While they can change shape, their volume remains unchanged, meaning the liquid will always take up the same amount of space regardless of the shape of the container. Liquids can slightly be compressed. However, it is so minimal that we generally say that liquids can't be compressed. Gas particles move around freely with high amounts of kinetic energy. Gases don't have a fixed shape, and they will expand or compress to fill whatever container they are put in. The way we show the movement of gas particles in a diagram like this is by adding little tails to each of the particles to show that they're moving in different directions and with high speed. Hopefully this video has helped you to understand how particles are arranged in solids, liquids and gases, looking at particle theory, and that you'll be able to describe that arrangement and the movement of the particles in each of those states of matter.